session. So in this session, we are honored to have a distinguished speaker, Mr. Anton Yudana, who will deliver his speech titled Agriculture Monitoring Using IoT. But first of all, I would like to introduce Mr. Anton Yudana. Mr. Anton Yudana received his engineering degree or SD degree in Teknik Elektro Telekomunikasi Multimedia from Institut Teknologi 10 November in 2001. In 2005, he finished his master degree from Teknik Elektro UGM. He continued his study to doctoral program in University Technology Malaysia and graduated in 2010. Currently, he is a lecturer in Electrical Engineering Department in University Ahmad Dahlan, Yogyakarta. His interests include robotic controller and artificial intelligence. So in this occasion, Mr. Yudana will deliver his speech titled Agriculture Monitoring Using IoT. So you have 25 minutes, including question and answer. So Mr. Yudana, the floor is yours, please.
Good morning for our excellencies and our distinguished lecturer, researcher from any universities in Indonesia, especially for our general chair, Dr. Rusdi Umar and Dr. Iskandar, and thank you so much to Dr. Hernawan. In this time, I will present my research on IoT, Internet of Things. It is applied in farming or agriculture. For a moment, I will play my video about our profile of Agrimon. Agrimon is an acronym from Agriculture Monitoring. Why we choose this topic on agriculture? We are very realized that Indonesia is agrarian country, so we have to give the special focus, and agriculture on also one of the research agenda, our research agenda in Indonesia. Okay, IoT, I think all the audience now is very familiar with about IoT, Internet of Things. It is skip. IoT now is very growth. Maybe it's called Big Bang on digital technology, and many applied in some of focus. There are smart home, maybe a smart city, and also self-driving vehicle, biomedic, and smart agriculture. And we choose for the smart agriculture. And we give our product is Agrimon. Agrimon stands for agriculture monitoring. What is Agrimon? Agrimon is the system that we utilize an IoT technology to monitor the water and soil quality monitoring. In the first step, we try to the paddy farming in Joko Tirto, Berbah, Sleman. And last year we start to the hydroponic farming, and continue to the stream ponds in the Bantul district. Actually, in Yogyakarta we have many destination or many spot of agriculture. Even it is on paddy farming, hydroponic, and also to the stream ponds. What is the parameter? First, we will get from the water on soil that we monitor. It is first we sense on moisture, and then temperature, and start when we apply in hydroponic, we get the new challenge on nutrition. So we have to find the proper sensor on nutrition, and fortunately we have get the special sensor to get the nutrition parameter. It is on TDS sensor. pH, I think it is very common in our instrumentation, and water level and so on. It is the architecture or diagram block of our system. We use the controller, microcontroller, and we use the Arduino, and we connected to the system connected to the provider. So maybe about the provider, it is very tricky there because some spot like the screen points in Bantul, maybe some cellular provider maybe not good. So it is we will change with maybe another communication transmission. Okay. We hope from the system that we socialize to the farmer will get the much benefit. About the remote off spot farming, maybe for the future it is not obstacle again. And second, the young generation maybe will interest to the agriculture sector, because when we visited to the some of associasi or kelompok tani in Indonesia, actually in Yogyakarta, most of them they are the old people over the 50. They are very neglect to us, so we have to choose the technology that make the young generation they are enjoy to involve in the farming. And the agreement also can monitor from the website and from the APBS, Android APBS. Agreement have the web development has done, and then hardware development is okay, and validation the data. Now we running in progress to get the certificate from the Balai Besar Kulit in Yogyakarta to calibrate our system. Hope from the certificate we will get the CAN certificate from our product. It is the achievement from the last year is very common. Before we just using the ThinkSpeak. Why we use the ThinkSpeak? Because in electrical in Ahmad Dahlan University we don't have the concentration of IT, information technology. This is to introduce to our students. So our research before we sparing to the sum of title of final project of our undergraduate student. Also this project we offer to the master student at the Magister of Technology, Information Technology. Before in the 2016 we just testing and calibrate our sensor to the sum of spot the paddy farming. What is the most important parameter that we have to measure or monitor? And from the farmer we get that paddy farming it is a very challenging. Actually for the soil monitoring or soil parameter monitoring, it is totally different which compare with the water parameter monitoring, because in the soil in the same square, the characteristic of the soil will be different. So about the soil parameter monitoring, we skip for a moment and then we move to the water quality monitoring. In the testing and validating our the sensor, we go to the farming. For the first step, they are farming before harvesting, because in paddy farming, the 2 until 3 months they have to drop their farm, because it is the time to get the harvesting. We use in this lab work, so we check our sensor. It is about the accuracy, about the linearity, and about the precision of our sensor. This is our lab workshop. Actually, we have the workshop. We coordinate our student, our undergraduate and master student, to join to our research, to join to our group research. It's called CEERDUAD, Center of Electrical and Electronic Research and Development. And in this step, they start from design until to the install. Also, they check testing in the lab test process. This is our workshop, and Alhamdulillah, start last year, our research, continue to the schema of CPBT, calon pengusaha pemula berbasis teknologi, and actually pass this step, and we have to provide the fundamental of commercialization. So we have to make the legal workshop. So we make the CV, and we give the name. The CV is Dilan Utama. There we share together on the alumni and also the active student, even they are undergraduate or master student. And sometimes for the kerja praktek, some of our students, they can join to our workshop. Okay, this is some activities in our workshop at CV with Dilan Utama, and actually I become the leader there. And after we get the agreement that first time we try to the paddy farming, Alhamdulillah, we continue at the same platform. We continue to the others brand, to the screen ponds. We name the product is IPUDA, electronic pemantauan udara, and we have the mitra from Bantul, some of the owner of screen company in Bantul, Yogyakarta. And for the rural area or urban area, urban area like the Yogyakarta, we have 3 main rivers in Yogyakarta, but maybe all same with other city in Indonesia. It is more difficult to find the good water quality in our river. So we propose our system to monitor the water quality in our river, terutama especially in Yogyakarta and Bandung, maybe in Jakarta. And we name our product Kalpin, electronic Kali Pintar. When we choose about Kali Pintar, we hope someday from the authority in the government, on the society, on the people, we can check the water quality from our river online and real time. It is proper on. It is good for our body or our bodies or not. It is secure for our health or not. The decision may be the water from the river maybe just to take a bath maybe, or just swim, or it is a danger from swim even to the take bath. And the last, we improve our system that before just or only monitor, we add some feature to get the feedback to control it, and we name our product. The third product is Simon Cori, System Monitoring and Control Irrigasi. The Simon Cori has implemented in Serumbung Magelang, and we get the mitra from hydroponic owners. Their company name is Damar Farm, and long 3 months the Simon Cori have implemented there. After we get the data from the parameters of nutrition in the hydroponic, so what will we do? What we have to actuate some actuator. Maybe it is just simple. It is simple, but for the owner of hydroponic, they are it is very important, because they have to daily monitor, daily activate the pump, activate the mixer, and so on. And Alhamdulillah, our product Simon Cori have solve the problem. So they have not to go to the hydroponic farm daily, because the pump and mixer or mixing the nutrition, they are automatically. This is our first step of Agrimon, like I present before at the Joko Tirto, Berbah Sleman. Only 4 parameter: pH of the water, pH the soil, moisture, and also temperature. This is the manual book for our Kalpin, Kali Pintar. I'm sorry, this was not Padis water, but for the river. It is Agrimon implemented to the screen ponds in Bantul, Yogyakarta. It is water pH, salinity, and DO. Special to screen ponds in Bantul. They ask to our team to add the one parameter, this DO, dissolved oxygen. Because dissolved oxygen, it is correlated to the screen growth. It is correlated to about the screen disease and so on. And after we get some parameter in the range, the spatial range, what we will do, we will actuate the paddle wheel in the screen ponds. Okay, this is the Agrimon that we deployed in the Serumbung at Serumbung Magelang. This is Kalpin that we coordinate our student to get the data at Winongo and Sudi River in Yogyakarta. And this product 2 weeks ago we presented to the PCTA, Parada Cinta Tanah Air, in held by Departemen Pertahanan. Alhamdulillah, they get the favorite awards at this event. And this is the installation for screen monitoring in Bantul. This the monitoring for hydroponic, and this review by BPPT and LIPI special Direktorat Penguatan Inovasi. Okay, before I will close my presentation with the profile of Agrimon, maybe we have still have time, Prof. Indra, Dr. Indra. Oh, 3 minutes. Okay. Okay, this is the box. We minimize our system or box before maybe before maybe the box dimension is big, and for this year we success to minimize to make the efficient is the sensor. Maybe for the electrical student or electrical lecturer, it is very common about the sensor and so on. But how we implement our knowledge to the applied in our environment in Yogyakarta. This is our mitra or partner from Damar Hydro Farm in Sumbung, Magelang. That's the temperature and humidity, and also the most important it is TDS. This is the hydroponic, one of the hydroponic company in Jogja and Jawa Tengah, and they are export their product to the Taiwan and also Japan. It is the mix a pump, mix a box to mix between nutrition A and nutrition B. Okay. Most of them that's lettuce and maybe spinach, red spinach, and so on. You just control this two nutrition A and B, and the sensor, the main sensor, it is TDS sensor for hydroponic. I think that's all because this video it is around 6 minutes, and my time it is just it's over. I think, Dr. Hendrawan. Okay, thank you.
Thank you very much,